three analysis. So that's the point where I came. Like I have to do something in cybersecurity apart from the traditional web to security. Firstly I am a cybersecurity consultant working with all these technologies, and in my current position, I'll do web application penetration testing, mobile and networks, and also this is my daily job. So this in my current position, I don't have an opportunity to work as a blockchain smart contract security analyst, but I am a evolution. I would like intermediary. See, when you deposit some money in your bank account, see, latest day I have one. Even or I have one. I got to know there is some point in banks where if you invest 1 lakh or 10 lakh rupees in your bank account, you are expected to be credited as 10 lakh rupees, right? So when I was when I was given the 10 lakh rupees as cash, they deducted around 1,000 rupees as a part of handling charges. So at that time, I feel like we are depositing money in, we are ensuring that they are safe. Okay, we are giving them our whole potential what do you say earnings and all. So it's for daily bread and butter, and still they take 1,000 rupees. So that's the point where I really frustrated. See, why we need banks here? We have internet over here. See, in India alone, we used to pay money via phone pay, UPI, etc. See, that's the world we are in, and still it is on development side. See, Web3 is always is behind of Web2. I agree with that, but someday it gonna pop up like it's pop up like Bugatti. So that's it. So coming to the point, we gonna talk about smart contract security vulnerabilities, and we're going to look into the basics of smart contract as well as blockchain and some sort of Solidity. Solidity is the programming language used to develop smart contracts. So we'll look into everything. Okay. So let's start. Okay, I'm going to share my screen so you will have a picture and representation instead of me talking in the screen full time. Okay, that sounds a little bit
So,
good.
Sridhi, before starting, can you check your voice? Probably little distance is there. Vanita, are you feeling any distance on the voice? Or are you okay?
Yeah, there is some disturbance.
Just a minute. Just give me 2 minutes. And there's a
Yeah.
fan running. It's hot in Mumbai now. So, yeah.
Okay.
I hope now it's clear. I guess.
Yes, yes, yes.
Yo. So that's the problem we have. Okay. So let me share the screen. Entire screen. No. Okay. I hope my screen is visible.
Yes.
Yes. Okay. Now let me move this aside. What is the
Mm,
slideshow? Yeah. Okay. Now let's start officially talking about smart contracts here. So, as I already introduced myself, I'm Srideep. I am certified Mitra attack and defender, and I have a lot of experience in identifying, mitigating cyber threats, contributing to cybersecurity community. So this is the basic introduction about me. So let's start. Okay, so whenever we heard about blockchain, the first picture come to our mind is Bitcoin. See, Bitcoin. Let's say that if you invested around five or if you buy around 5 or 6 Bitcoin when it was launched, okay, then you have millions of accounts in your account right now. So that's the nutshell here. So this is that is Bitcoin is part of blockchain, okay, and Bitcoin is not blockchain. Bitcoin uses blockchain technology to do transactions and other kind of things. So what is blockchain? A blockchain is a growing list of data blocks that are linked together. So consider we have one a network, okay, and if you are hosting your own node, okay, let's say that I'm hosting an Ethereum node on my system. When we are installing the Ethereum node, the day from the day one to the last minute, there's a ledger. Who are transacting monies, or who are transacting their tokens or anything. These all are been accordingly stored in every computer. So that's the thing when it comes to the blockchain. No one can change the data. Once it is there, it is there. See, if I changed, let's say that I paid 10 million US dollars to in another account, yeah, I claims like that rest of the nodes having the same copy of this ledger. So they're gonna say that it's a fake one, or it's not the legitimate one, because everyone hosting the same ledger, so everyone is listed over there. So that's the beauty of blockchain, and that's the what we say. That's the good thing about blockchain. It's everything is transparent here, and everyone holds the data, and everyone has the same privilege over here. So that's, I hope that is clear as a blockchain. So moving to the next part, and yeah, like what I said, Bitcoin is part of blockchain, okay, and Ethereum is also a part of the blockchain. The smart contract, the concept of smart contracts uh, has been came through Ethereum, because Ethereum is the programmable blockchain. In case of Bitcoin, we have true or false situations, like spending, let's say, space be equal to, like that. So that is only limited, in Bitcoin. We have only limited capability of programming, but in case of Ethereum, it is more advanced than Bitcoin. Okay, so that's the main thing here. We can host smart contracts. Smart contracts is something a code which is hosted on Ethereum blockchain. So that's the thing. So Bitcoin is different, and Ethereum is different in its own way. Okay, and considering the generation wise, Bitcoin is the first generation smart cryptocurrency we have, and we have second generation is Ethereum, and the third generation is on fighting with Solana and Cardano. So I don't know what would be the third one, but Ethereum is the, it is the base of the blockchain. So when it comes to the writing smart contracts, Solidity, we use a programmable language called Solidity. Okay, Solidity is an, object-oriented programming language. If you are in the background of coding, or if you study BCA or computer science in graduation and all, you might see this code is little bit easy, because it uses the same concept. Only some sort of only some things are different here. I have listed over here Pragma, and then Pragma is the visual sorting takes, and Pragma is the one who defines which compiler we're going to use. So that's called Pragma, and I'll show you the original smart contract from the original real world scenario. Okay, and the contract is some similar to classes, and modifier is reusable code. I just reading it for you. Okay, and for the function in Solidity is a default function that is executed when a contract receives either without any specific function code serving as a catcher for or an incoming transaction constructor that runs only in once. That means if I if I deployed a smart contract, so I am the owner of it. So that will be declared in the declared as constructor. So it runs only once. Okay. So consider I have talked about blockchain, and it is immutable and it is decentralized. So the technology is almost impossible to hack. Uh, that's the thing, because it developed and it works in that manner. So it is almost impossible to hack the blockchain, because there are a lot of attacks considering on blockchain. 51 percentage attack is the something when an attacker holds more than 50 percentage of the blockchain nodes, then he can manipulate some sort of data. So that is, there are vulnerability in blockchain technology as well, but it is theoretically it is okay, but in practically it is very difficult to exploit such huge esteem technology. So so then how the hackers stole millions of dollars? So that's the thing here. They are exploiting smart contract. So they once they exploit the smart contract, they will hold the money to another account, then they'll cash it out. Right now, as per the cyber attack trends, most of the APT groups, advanced persistent groups, are targeting smart contracts and cryptocurrencies. See, it is really tough, but it is possible to hack. A person with good mindset and great dedication, we can hack. So this is how hackers steals money from blockchain, exploiting smart contract. So I talked about smart contract so many times. So some of you might wonder what is exactly the smart contract is. Okay, consider we are on a fundraising program. Okay, one of us friend is in hospital. We need around 10 crore rupees for his medical usage and all. So we are collecting money from the people. Okay, as a contribution kind of thing. Okay, so but in traditional conventional marriage, a person will come to you and say that we are looking for some sort of contribution to help the medical conditions of my friend. Okay, so we have to trust that guy. See, if I am making a contribution, I have trust this guy whether this guy is going to do the same thing as he promised or not. So we need some sort of trust before we sending that money to him. Okay, so that's the problem we face in the real world situations. So that's where the smart contract comes. The code is the law here. Okay, and the code says that if the contribution is equal to or greater than the required money, then it won't accept the next contribution on all. Okay, if some cases what happens, like most of the people will say will invest or will contribute the money more than the required money. So it is the we in that case also we have to trust this guy after the particular required money, but rest of the money what he want to he doesn't know about it. So when it comes to smart contract, if the contribution there is a condition, if the contribution equal to or greater than the required fund, then the whole fundraising platform will end. Okay, so none of the money is used, none of the money is being pictured here. So that's the thing. It's simply saying that it's a program we input where we solve the real world problem. So that's the thing. Called smart contract, and it is hosted on the blockchain network. So that's why it becomes smart contract. Okay, so yes. So is smart contract really smart? Some of you might think like that. Is smart contract the name? The names when we hear smart contract, wow, yeah, it sounds really good. Smart contract. So most of the people will think that is there really smart? Actually, it's not. It's not the smart as you think. It has some sort of vulnerability. So that is the thing which we want to say here. See, the smart contracts are prone to security issues or vulnerabilities. Okay, so there are I have listed four of them well-known vulnerabilities here. That is one is re-entrancy, integer overflow, initialized storage pointer, and DDoS or DOS. Yeah, these are the main vulnerabilities. Which are these are the main well-known vulnerabilities here. Okay, and in most of the smart contract, we can see mostly it's an access control type of vulnerability. Okay, in the real world, when I was auditing some of the contracts, I what we say, I'm seeing every day like there's some sort of access control problems here. So that is the main vulnerability which is from my experience. These are theoretically you will get it, but when it comes to the original path, and you will see uh, some sort of high level vulnerability as well as low level vulnerability, but it is really up to the person how he analyzes the code, how he sees the thing. So my analyzation will be different from the other person. He'll analyze in a different manner. So both of them have a couple of findings, uh, which is which is not the same, which doesn't use the same methodology to obtain that kind of vulnerability. So this is the thing. This is a just remember there are well known for vulnerabilities here. There are a lot of vulnerabilities first of all, but as you know, in case of web application, we have OS top 10. Okay, OS top 10 will be updated. Lastly, it is on 2021. They updated the list like that. See, in OS top 10, you can see there are trending vulnerabilities. Okay, what are the trending vulnerabilities on Web 2 security? That is what the watch top 10 or watch team is using. So like that, I have listed this for vulnerabilities here. Okay. So sometimes when I say about the coding exploitation part, actually some of you might think that
Srideep,
uh,
there is a question on DOA attacks. So can you explain the
oh,
DOA attacks? Yeah.
yeah, yeah, actually, I was about to say that DAO attack, decentralized autonomous organization. So that is a organization where they lost around 500 billion or million um rupees US dollars in just for a small vulnerability. Okay, that's the biggest event which happened on the Web3 security timeline. Okay, so DAO hack is something they are the hacker exploited the re-entrancy vulnerability. It's a history. Okay, this using this vulnerability, he was able to drain all the funds in that particular contract. So, see how re-entrancy happens. You know, it is really simple. So consider you and I'm sending you money. Okay, yeah, for the group or something. Okay, so when I send you the money, let's say I'm sending to a person B. Okay, when I send 10 rupees to a person, and if the transaction got successful, the 10 rupees will be deducted from our account. Okay, so this is a flow. So what if the transaction doesn't work? Okay, and I keep sending 10 rupees, 10 rupees, 10 rupees. Like we in real case scenario, we sometimes we go to the shops and we do phone pay, right? So at that time the transaction might be failed. Okay, at that time what will do? You will do the same transaction again. So that's how the re-entrancy work, because before updating the balance, he was able to capture all the funds in that particular contract using a special function called receive function. So there is a receive function and a fallback function. So if a receive function is a function which is not validating, it is like I have one slide here for picture or representation. I'll come to that point. Okay, just for answer the question, re-entrancy is the vulnerability the hacker used and exploited, and at that time when it was happened, even like Ethereum was having some sort of what we say, Ethereum was having a good market on blockchain, and after this hack, there is the Ethereum has been split, has become split because due to the intensity of the attack. Now we have two Ethereum. Okay, one is Ethereum and one is one more Ethereum. I can't just remember. I can't remember that name. We have two sort of Ethereum right now. Uh, I am not even remembering that. So that's the impact of this vulnerability, because the Ethereum itself loses its value when it was exploited. Okay, so coming back to my slide, I hope that answer is acceptable.
Is this because of the latency?
In latency, actually, as I explained, latency we can say like that, because before updating the balance, before reducting the balance, the attacker was able to send money to its account. So latency can be a part, but re-entrancy is something is the main reason for this attack. Okay, is that fine?
Okay.
Yeah. So coming back to our slides. So now, yeah, some of you might interested in auditing. Yes.
One more question. Can you
Yeah,
release
yeah.
the open
Chat.
chat?
Yeah. Sure. Let me see where is the chat.
Can you
Q&A.
please give some background about how smart contract is actually executed? I think you are going to give now, correct?
Yes, actually, see how the smart contract is executed is simple because
Yeah.
once they do the transaction, it is going to disturb the entire blockchain. So that's
Okay.
how that's how whole smart contract concept works.
Okay.
We are holding a lot of nodes all over the world. See, if I listed one of the contract in smart contract, it gonna list entire blockchain, entire systems which is all around the world. Say anything, if I do anything, it is public and it is open to everyone to see and audit.
Mhm.
Okay.
Okay. So you're going
Okay.
to some demo on, correct? That will be answer
Yeah.
this question.
Yeah, and actually, I'm planning to show you some sort of CTF, and you will get some sort of idea how to exploit the things. Practical sessions are on the way.
Okay. Go ahead.
Okay.
Thank you.
Okay. So, talking about smart contract auditing, and some of you might think that we really need to learn the solidity language to audit or to start into Web3 security. But when the chat GPT came to the play, the coding part become easy for us. See, if you want a small scripts, then you can just ask to chat GPT and he'll write for you. Same goes to here also. See, most of the times how smart contracts are attacked using an malicious contract. See, in smart contract, since it is hosted on block, they can talk each other, they can call functions each other. So consider we have one vulnerable smart contract hosted in place. Okay, and I know how it can be exploited. So I have analyzed the analyze the way it's working. So using that logic, I'll create another evil contract or malicious contract to attack this contract. But for developing such contract, you need a programming skill. There is no doubt in it. You have to have some sort of programming skills. But ChatGPT can be used to make this evil contract and also. Right now the trend is on AI and also why should everyone want to learn such programming language? But it is always I always encourage people to go and learn Solidity, so that won't be a problem. So any knowledge is a wealth. Knowledge is always a wealth. So if you learn anything that gonna be that in the long run it gonna benefit you. So if you really want to if you really want to make millions and just make money is your policy, then you have to learn from scratch. That means from scratch, from Solidity basics, programming basics, and after that you have to do some sort of CTF, and you have to get know how these things are working here. So once you are on the right path, once you are on the correct path, then you can actually you can make money using your skills. So that's how the bug bounty people are doing. So most of the people are not going for any daily jobs like most of the people do. Okay, they are exploiting or they are finding bugs for a big companies. Let's say that Facebook or Google. If you find an RC on Google, then then your time is set. Okay, you they want to pay you in around 12,000 or 23,000 in that much of money they will pay you as a reward. So most of the people are doing that only. In security field, we people have a distinction kind of skills. See, if you took 10 peoples might have 10 different skills. That's the beauty of cybersecurity. No one holds entire skills. Okay, no one in the industry knows A to Z things here. So we all know little bit of things in cybersecurity, and we are sharing that to the another person. So share. I do believe that sharing is caring. Even if I have some sort of knowledge, if I share to a person, even if I share to a person, he knows something about this. Sometimes he knows something about this, the topic which I'm talking about. So he's gonna help us. So both of us will be benefited here if you are sharing your knowledge to the community. Okay, so what I was about to say that if you wanna really enhance your skills in blockchain auditing and all, you have to have idea about object oriented programming, and you must able to read the code. Okay, so that's how we can go forward. Okay, you can use ChatGPT or any other AI tools available with you. We can use it, but at the end of the day, you have to you have to get the idea what you are doing. Okay, so Okay, let's start the practical. So for practical session, I have an Ethernote. It's a what we say. It's a CTF kind of thing. So this is where I studied and trained the smart contract vulnerability here. So this is the first challenge, and it's the easy one. Okay, so why it is not loading? Just give me a minute. Yeah. So when you're auditing a smart contract, this is the code which you want to see. Okay, a smart contract itself is a code. So you have to go through the code and you have to find the logic of the code, and that's how it is done in the proper manner. So we gonna hack this particular contract. Okay, so that's the thing here. So let me read the code. Okay, so firstly we have pragmaturity one. As I mentioned earlier, this is mentioning the version of compiler which gonna use to compile this code. Okay, so and we have contract fallback. So this is the contract named as fallback. Okay, so mapping for address using public contribution. There are contributions and this is public and anyone can call this particular function as well as an address public owner and this contract has an owner. If I type here, okay, contract dot owner, so you want to see that contract dot owner, yes. Wait, yes, wait. So see, let me clear this. Clear this. Okay. So I forget about it. Okay, see, this is the address of the owner. Okay, that is message dot sender equal to owner. So he is the person who is the owner of this particular contract. So and there is a constructor here who says owner equal to message dot sender. Whoever deploys this contract is become the owner. So that's how it works. So owner equal to message dot sender and contribution of message dot sender equal to 100 star E. That is a huge money. See, one ether is there's a one converter here. You know what is that? A ETH converter or something? Converter. So there are in case of unit converter, yes. So in case of rupees, we have paisa. Okay, so like that in Ethereum also one ether and one G, one more unit called single converter CP, and one ether equal to this much of day. So that means one ether is this. Okay, so one ether is this. I hope this is understandable. Okay, so just assume that ether is the most one dollar. Let's say that dollar and cents. So that's the difference between ether and bay and J. Okay, so coming back to our CTF. Okay, so contribution of message dot center or the owner contribution is this much. It's a huge money. Okay, so modifier require message or sender equal to owner and caller is not the owner. So that is a modifier which is a reusable code in the contract or in the smart contract. So modifier is the keyword here to implement modifier kind of thing. Okay, and we have function here which is public payable and require message dot sender message dot value is less than 0.001 ether. Okay, so whoever is contributing to the contract must be lesser than this amount. So that's how it is mentioned here. And the contributions message dot center equal to message dot value. That is, I hope that is understandable. Contribution of message dot center is plus or equal to message dot value. And if the contribution, if statement contribution or message dot center is greater than the contribution of owner, then he become the owner equal to message dot center. That means if you want to own this particular contract, then you have to give more than this money which I mentioned before. So that's the only way you can become the owner of this contract. Okay, then we have public view returns you in return contribution message dot sender, and see, this is the point where the problem lies in, because see, this is a receive function which I mentioned earlier. Receive function is a, it's a it's a critical function where the required message dot central value is greater than zero, then contribution dot message dot central is equal to greater than zero. Thus, it becomes owner equal to message dot central. So I hope this is the logic is understood or not. Let's see. Let's assume that, or forget about the code which I said. Forget about everything. Just assume that this is a contract which says that if more than 1,000 ether, okay, 1,000 ether. If you give more than 1,000 ether, you become the owner. So that's the flow here. So as a hacker, okay, hacker, this code is publicly available with every person from the internet. So there might be hackers too. So hackers point of view, we can see this is a receive function which is does not validate anything. So let's start a new instance. Okay, so let's start attacking the contract. So when you set up in the Web3 or the CTF environment, you have to use a wallet called MetaMask. So MetaMask is the extension here. So you have to maintain some sort of ether. We are using testnet for in Ethereum. We have two type of network: main network and test network. So we use test network for the for this CTF and all. Okay, so now it gonna say your confirmed transaction requesting a new instance. So it will create a new instance with new owner. And after that, yes, transaction has been confirmed on Sepolia Etherscan. Okay, now let's see. See, if you type await.contract.api, you can see what are the functions there. I hope you can able to see it. Okay, there are functions called receive function, contribution, contribute, get contribute, owner, withdraw function. So these are the functions available over there. Okay. And I wait owner or contract or owner will say who is the owner of this contract. Okay, it's a function. So this is the owner of the contract, and mine is player. So this address is not equal to this address. So I'm the player here, and this is the owner here. So I'm gonna become the owner of this contract uh, without contributing the required money. That's how we can hack this contract. So firstly, we need to send little bit of contract. Okay, get contributions. So here, wait, get contribution, get contributions, get contribution. Okay, wait, contract, get contribution. See, it is zero because we didn't contribute or nothing. Because if we contribute something, it gonna show, it gonna reflect here. So I'm gonna contribute a small rupee or small ether with it. Okay, for transacting money. So this is contract dot contribute. So
So, Sridhi, which platform you use to manipulate that contract?
we use platform as in I didn't get you.
Which platform you use to hack that contract?
See, since this is a test network, we have in this contract is implemented on Sepovia. I can show you here. Wait. So this is a test network where people host their smart contract just for testing this kind of things. Okay, So that is here. See, so this is the test network here. As you can see, my account is on test network here. Just a minute.
This is only possible in Ethereum, or it is possible in other platform using Ethereum?
See, in the Ethereum not only sorry Solidity is not only used on Ethereum. Okay, it can be used on other platforms like that we need to check. There are lot of coins using a lot of cryptocurrency using Solidity as a programming language. So our goal is to look only for Solidity. Okay. In case of Cardano, they have another programming language to host their smart contract. Like that, most like that, each cryptocurrency have their own programming language to host the smart contracts and also what I am meant to say that Solidity the Ethereum not only Solidity not only used in Ethereum. Okay, it can be used in other platforms like actually I'll list out so that the viewers can see it is not limited to limited to Ethereum. It can be used in other platforms as well. Solidity as a language. So, see, Binance is the most famous one. Binance. See, that's what I told. I told you know, like once the DAO hack was happened, Ethereum split to two. So that's why we have Ethereum here, which uses old ledger, and we have Ethereum Classic here, which uses the new one. So what happened, you know, at the DAO hack time, since the code is immutable and something is done something if you done something it should be there forever, right? So that's the whole concept of blockchain, and some of the community member was saying that we need to refork the Ethereum blockchain to you know to go back in time, like this have cash don't happen like that. So some of the people are not happy because they are saying that uh, it is not ideal. It is not ideal to refork the Ethereum blockchain or Ethereum blockchain. So they split it to two. So that's why we have Ethereum Classic and Ethereum, and these are the cryptocurrencies who use Solidity as a programming language. So once you study the Solidity as a programming language, if you know Solidity to write smart contract, then you can host in Ethereum as well as Tron as well as Hydra, Polygon, and anywhere. So you have a lot of platform to host your smart contracts in future. So that's what I'm gonna say. Okay, so coming back to our contract, so this is hosted on Sepovia's testnet, and previously the MetaMask used to say that it is a
So,
test network and all.
other question is there any
Mm.
way to do the same
Mm.
ownership change in cryptocurrency?
Come again?
Is there any way to change the ownership the way you do it for Ethereum?
Yes. Mm-mm. Yes, of course. See, you have to find the logic of the code, and you have to study where is the loophole to exploit and to become the owner of the contract and all. So in this case, I told you like there is a mistake in the last session of the code. So that here is the mistake. That means here exactly talking about here. Here is the mistake. So they have to verify there is only one line of code is missing from here. Okay, that's the main point here. Because even if you miss one point in the smart contract, then once it is hosted, it is there forever. Okay, so you have to be very careful when you write such code because you are handling the huge money here. Okay, and any person on the internet can see such codes online. So if you look at the other way, the smart the white hat hack is like me being if they host a code on the blockchain, we can see that such code, and there is a platform you can actually see what's going on at Ethereum or what's going on the blockchain. This is the website which lists the smart contracts. Actually, I can show you some sort of smart contract here which is running on the crypto platform. So it is which is might be trending one. So let me enter this website. Okay, and also coming about, see, some of the people knows about this Bitcoin and all is used in dark web, right? So some people will think that why it is used in dark web, because it is totally the person is identified using a particular hash. So in that case, I told you the owner of this contract is identified using this hash. Okay, so and that's how they send money each other and do such illegal activities online, because their identity is really protected over here. Okay, so this is the Etherscan platform where you can see actually the transactions. See, if you go on transaction side, you can see. See,
Is it
9 seconds
live?
ago it is,
Is
yes,
that live?
9 seconds. Yes, yes, yes. 9 seconds ago, there's a transaction between this guy from this guy to this guy, and there's a transaction hash will be generated as a in database side we have unity, right? So there's each time each transaction generate a hash for identifying in future. So this from this guy to this guy they have sent this much of value Ethereum. Okay, and the tax fee and all. There is a, if you what we say, if you send money to another account, there is a particular amount you have to pay for gas for calculating or making this transaction happen. For that is called gas money. So that's the fee here. Okay, so let's say that if I send you 10 rupees, so 2 rupee would be the transfer fee or something. Okay, so you can actually you can optimize the gas limit here, because if you write the code in that manner, or like if you really know how to optimize things here, consider 10 million US dollar can be sent to a person with less amount of gas. Okay, so that's totally depend on the person who actually write the smart contract. So if you write such code, you have to be careful. First, you have to be careful to whether you include all the codes or not. And secondly, you have to make sure that everything goes very well, because the mistakes here is really going to cost you. So that's what I meant to say. And reason why I came to this page is that there's a smart contract can be listed over here. So let me see if I can show some existing smart contracts. So let's see. Just go to here. Last transaction. Last transaction. Actually, it is little tricky to find the smart contract, but since this UI is constantly updating, there's an option here previously to see the smart contract. So right now, I am not seeing that. My bad. But if you click on here, let's see. If you click on, yes, this is my exchange token transfer. Transaction. Yes, source code. Let's go on the source code have been verified. Okay, this is a contract, and we do have source code here. So there is an option to use the source code previously. But let's see. This is video.fi source code. Source code. This contract. See, this is the code. So actually, this code can be copied, and you can actually copy this code, and you can actually audit this code. So let's see that. if I find any vulnerability here on this particular constructor side and all, I can, what I'll do is that there is a contract. This is the idea of the contract. Okay, so I'll deploy another evil contract to exploit the logic of this contract. So that's how it is done in real life. Okay, that's the same thing which I am showing here or as a CTF. I think it is, it's
Okay.
a good explanation.
Okay, go ahead.
So yeah, so coming back to our CTF. So I'm going to translate a value of 1 here. Okay, so to this contract, and MetaMask will pop up. Yes, MetaMask has pop up to transact such money from my account. So estimation fee. See, this is the thing, and maximum fee and total gas. See, amount plus total gas is this much. So I'm going to confirm the transaction. It changes. No, I'm going to confirm the transaction right now so that we can actually contribute on Ether to this contract. I see why it is taking some time, because it need to be executed on the blockchain level. Okay, on the blockchain technology. So that's why it is taking a considerable amount of time. Every time a transaction happens, every time a transaction happen, they also create a hash for such transactions. So that is done with the help of this computer. So there's a what we say, there is a hashing, there's a mechanism to generate hashes for each transaction, and that is also written in code. So that's why it is taking some sort of time. It taking some sort of computing power to make your transaction. So some people, I have some friends who actually mine the Bitcoin as well as the Ethereum. Okay, they host their own mining setup and they mine the coins for themselves, because it is really hard to mine the coin first of all, but it
Are you
can be
doing
possible.
on are you doing this hack on cloud or in your laptop?
This particular, you mean this environment, right?
Yes.
Yeah, this environment, to get understanding, I'll show you one thing so you will get a understanding, proper understanding how it is done. See, here, let me create a new file. Okay, let's create, this is an IDE for developing and deploying smart contracts. So Remix is the well-known one, well-known IDE for Web3 people. So like, let's say that VS Code is popular on developer side, right? So like that we have Remix here. So first code fallback is the name of the contract. So and the extension is Sol, because it's a short name of Solidity. Okay. So here I'm gonna copy the whole code here. That is a warning, because you are blindly copying the code word somewhere, so it might result in some sort of damage, mental damage. See, now the compiler we are using is 8.0, so we have to change to 8.0, otherwise it's gonna error it out. 8.0, yes, this is, no, it is compiling, yes, compiling. After compilation, you will get a tick mark here. So it is also going to take some time, I guess. Yes, now you are. Now it is compiled successful. So when it comes to deploying, see, this is the environment which we can deploy. See, injector MetaMask is the environment which I am using. Like what we say, it is the blockchain technology for testing this particular thing. Okay, and it is connected to my MetaMask wallet. So if I estimated gas and what, if I implement here, and we can create another evil coin on the same network with the with what we say, if I deployed a evil contract to attack this contract, this original contract has some sort of identification hash. Like I said before, there's the hash used to identify every transaction, like that. There's a hash to used to identify every contract. existing on the smart contract, existing on the blockchain. So we wanna use that particular contract ID to attack. Okay, I hope that is understandable. Okay, so this is the environment. So that's what I meant to say, that this is an environment like that. We have a lot of environment here. See, remix itself got a environment just for testing and all. So since we are using cross platform, so that's why I was connected to injector MetaMask here. So maintain to my remix. So once you, this is the account, my account. Yes, last E7. If F15 E7 is my account, so it is linked to my account. Okay. Now, now we'll become the owner of this contract. Okay. So we have contributed ₹1 to this contract. So if you search for get contribution here, wait, get contribution. Wait, contract, wait, contract dot get sorry, get contribution. So you can see it is changed to one. Okay, now you have successfully given one ether to this contract. Okay, let's check again. The owner is not equal to the player. Okay, wait, contract dot owner. Yeah, the player it is not equal. But when I transact this, okay, contribution, this is the code. Okay, so again we gonna send one more.
Whenever you execute command, your voice feeble. Yeah, yes.
Execute. Yeah, because that is why, that is because the blockchain, actually I'm doing these things on actual blockchain, no? So it might take some sort of extra, extra MBs to process it, I guess. Get balance contract address. So we have contributed this. So when we contract that we do, there is an error. Okay, there is an error. So somewhere it is not good. Okay, let's, there it is. Why it is happening? Let's see it on remix.
Here, what is the hash length, Srideep? What is the hash
Uh,
length?
Hash length. There is a, we have to say hash length in bits now. So I don't remember
Is
exactly
it
what is that.
more than 200 plus?
No, no. It says around hash it's used to. I think there's an algorithm like SHA-256, like that. There's an algorithm. So using that only, we say what is the, see, this is the hash. So
256. Yeah.
yes, 256. So okay, what I was going to do is, I think, actually there is a program. Okay, let's come back to here. Where is it? So
Now you're looking for the change of code, or
no, actually, there is a one intermediate code is missing, and I have to figure it out what's missing here. So that's what I'm checking what I have missed here. Let's open the here transaction get transaction code.
all these are MySQL, or
No, no. No, there is no use of MySQL here. In contract, if you want to store some sort of data in it, it is not recommended to store data in it since it is very publicly available. So it is not, but it is possible with the suitable access control thing. If you implement like that, it is possible actually. But right now, I'm missing the code here. Okay, okay. Contract go. Okay, contract or contribution. And after that, we'll contact onboarding. Let's do that. External payable. Okay. This time MetaMask not pop up. Yes.
what was missing that?
I think this is the code which is missing because when I call the withdraw function, since that function is using a receive function, so this gonna make us the owner. Let's see. Okay, transaction failed. What is the error? So if you encountered an error in the smart contract, then it is really difficult to figure it out as per my knowledge.
If you have more slide, you can continue with presentation. Then you can come back with practical example.
Yes, I have actually the practical what I was meant to say on this practical is that see if even if you the code was looking pretty good, okay, this code looks actually very good. Actually, the given condition is simple. 1,000 ether need to be contributed, and only you will become the owner. But since it has some sort of access control or some sort of validation is missing, that's the problem here. So that's what I meant to explain. But sadly, it doesn't work as it is. Let's see. So let's continue on the slides. So okay. So this is what the question comes from. The an example of DA vulnerable code. So this is the example of the code which the DAO team was using. Okay. So using the say we can see there is a see if amount result minus amount. See this is the problem where it lost a huge money. So here only a 2 4 lines can result in millions of loss. So you have to be really careful, as I mentioned before. You have to be really careful to implement the smart contract. Okay, so the pictorial representation of re-entry attack. So this is the pictorial kind of thing, like for easy understanding. So here, as you can see, the contract B with the fallback function calls withdraw function continuously before the update balance function, thus resulting in draining all the contracts, or sorry, all the funds in the contract. So this contract A is the original contract, which is the original DAO team's contract. Okay. So hacker from the internet who analyzes this particular source code, and after that he deployed another code that is contract B with the fallback function in it. So once he send the money to this account, then it withdraws it, and then withdraw. See, this is the sequence: check balance, send fund, withdraw, update balance. So withdraw, update balance should be on come to the third flow. Okay, once you update the balance only, you need to withdraw. You have to allow this guy to withdraw his money. Okay, that's the mistake the DAO team was having, because they didn't update it. They didn't look for the update balance when it comes to withdraw. So fallback function is the function which calls a number of times. So firstly, he check the balance, he sends some sort of money, then he withdraws it. Okay, before the contract is programming or programming compiler checks for the update balance, he is continuously making the fallback function to call withdraw function every time. So within around, I guess within around hours, he was able to train entire tokens in the contract. So that is the thing which happened on DAO side, decentralized autonomous
So can we
organization.
use the chat GPT to find the flaws in the code?
Yes, that's what I'm going to show you. Okay, see, if you copy this code, okay, now the AI is really updated, and sometimes I feel like I'm not in the race anymore, because AI is totally taking so much of capabilities right now. See, I don't know if you checked on my cybersecurity news channel. Lastly, in my news channel, I was reporting that only, because the ChatGPT and single-handedly exploited one buffer overflow in the application, which is quite impressive. Okay, so hackers who exploit buffer overflow, who knows that particular, they knows the particular pain for finding and exploiting the buffer overflow kind of thing. This is not the like what we say, this is not the amateur thing you do on this platform like web application testing. But ChatGPT on the other side, ChatGPT was single-handedly able to exploit whole the buffer overflow concept here, so within seconds. So that is really impressive from my point of view, since this AI is so getting so advanced. So if I give this code, okay, so this is the code for the what we say, the fallback function, on the fallback code. So firstly, this solidity code is called. He'll explain the code in a manner that every person can understand. Okay, even if you are not what we say, even if you're not able to know the logic of the contract, ChatGPT is going to help you with that. ChatGPT really want to help you to know the codes, know the flow of the code, what are the keywords used in the code, and etc. So this is the thing which you are seeing right now. Because if you give any code here, the gonna uh, analyze the code, and sometimes he will say the uh, sometimes he will say the vulnerability here as well. Okay, so if you search what is the vulnerability here, what is the vulnerability here, the one see he identified the vulnerability in receive function. So as I told you before, this is the part where the vulnerability lies. So ChatGPT is single-handedly able to find the vulnerable part here, and even if you ask for the solution, he'll give you the solution. See, modified code is, we have done some sort of modification here, because see, as per the logic of the previous code, anyone can able to send only this smaller than or greater than or equal to this much of money. So that's the condition here. So he has re-implemented the condition in here. So if you, that's what I said, if you miss this, the even a single line of code, it gonna cost you. So this is the line which is missing from the contract, that's making it is vulnerable. So, okay, so so coming back to our slides. Okay, no. So I hope re-entrancy is clear. And as I mentioned before, there are top 3 or 5 vulnerabilities here. And for this session, I'm going to discuss a special vulnerability here. Only least people in the industry knows that. Okay, so that's the what is that is the critical information for you guys from my yeah, from my research and my point of view. Okay, so re-entrancy, I hope re-entrancy is clear. And we are moving to the next one, flow attack. Flow attack is something, see, we used to do ride vehicles, right? So in vehicles, if you cross 1 lakh kilometers, okay, 1 lakh kilometer, and it is going to start from the zero. So that's how it is. That's the problem goes for the smart contract. That's the issue with the smart contract as well. So since this whole thing is a mathematically calculating thing, things could go really bad, because if you must know about overflow and underflow. Uh, See, in our college times, we used to learn that array overflow and array underflow. So, if even if an array has 20 as a limit, and the program automatically sends 25 items to an array, it will goes an overflow. Okay, so the same goes for the underflow as well. So that is the that is a vulnerability, a potential vulnerability. Yes, see, underflow and overflow vulnerability can pose a significant problem for smart contracts, as these vulnerabilities can be exploited by hackers to manipulate the execution of the program. So, for example, consider a smart contract that calculates interest on a loan based on a fixed rate. Okay, so if you take a loan from the smart contract, okay, the smart contract calculates the what would be the final amount after interest rate and processing fee, and also consider we have one contract like that, okay, and if an attacker was able to trigger a overflow by providing an extremely large amount, okay, and the contract may calculate interest based on the incorrect value, so potentially resulting in loss for the lender. So similarly, an attacker can able to trigger an underflow providing a negative loan amount, okay, which could cause the contract to execute in unexpected way. See, same goes for the Web 2 security as well. See, I'm from work is Web 2 as a penetration tester. So, what we always used to say that whenever you take an input, okay, whenever you take an input to your code, to your application, or anywhere, you must be validated. That input validation is something we raise it as low. It's a low finding only, but the input validation has a potential to attack, to what we say, to gain entire access to our system. Sometimes, see, XSS and our command injection works in same manner only. Without proper input validation, the program can go in an unexpected way. So that's giving an upper hand to an attacker. If he sees something gonna error out, so you wanna assume that its payload has been worked. So similar, then from then on he'll escalate further what that error is. And see, the input validation and improper input validation and improper error handling is a low based vulnerability, but it is really crucial when it comes to an APT groups. APT groups, what they are doing is that they they have a dedicated team for the attack. First of all, okay. So even if you do proper input validation, and also they know how they'll find a way to bypass it. But how hard you try, it doesn't matter. They always try harder than you. So that's what I meant to say, that these vulnerabilities sometimes, even if you give me a smart contract to audit, I might say that some best industry practice is missing. So as per your point of view, you might be thinking that it is okay, but on the long run, it gonna cost you. But that's the warning I'm gonna say now. So that's it. So I hope this flow attack is okay.
So is there any example using the chat GPT you can show the flow attack and mitigation, something like that?
Mostly, flow attack happens on the Pragma, so compiler, which is way older. Okay, if you use older libraries,
This is
okay,
in the low level. This is in the low level of
uh, See, considering the example case here, the non-interest rate, okay, if I encountered a overflow here and that's resulting in less interest rate or something, then it goes too high because I was able to exploit it and I was able to manipulate the system, which is giving a financial or huge money as a loan. So I can able to bypass the fixed interest rate. So at that time, it the whole program code lies on this. Okay, so at that time it goes to high or critical. So consider in other case like consider other case where you are calculating something for something. Okay, so at that time if I exploited this overflow attack and there's such no impact, let's say there is no impact on it, so it goes to the low. So it ideally depends upon the logic of the contract as well as the vital role of the particular code. So at that moment only the severity can be analyzed. Okay. So yeah, this is what I told you before. Gas griefing attack. Most of the developers and most of the people are not knowing this attack. Since this attack is a gas optimization kind of thing, mostly I don't think they are not caring about it. See, when you are transacting a huge money and you are giving 1 rupee as a gas fee, so they never want to look into it. But see, if I want to attack your contract, okay, and there is no gas optimization, and I'm gonna deploy an evil contract. Okay, it's to call particular function of your contract. See, every time when my evil contract calls functions on your contract, it takes a what we say, it takes a computation power to computation power for generating hashes. So that's the reason. That's the main reason for gas. Okay, so it takes some sort of computational power to create a hash. So if I consider the case which I explained, the real case, if my reentrancy, sorry, if my evil contract calls the particular function that results in calculating hashes, okay, so this will give you a huge problem because you have to pay gas n number of times. So I can make that. Let's say that to make it more understandable for our say Web2 security people, let's say that I have using a mobile application. Okay, inside there we have a Google APIs. Okay, Google API for map facility. So when I was able to get the private API key of the Google API key, I can send n number of requests to that particular API. That's resulting in their billing side. Okay, so if I want to bankrupt a company, I can send billions of requests to that particular endpoint, and Google will bill you according to that because if Google can see that what are the incoming requests there, what are the incoming requests. So based on that only they are generating the bills. Okay, so if I want to really want to harm you, then I can send a lot of calls to your to your contract and making them as a as a loop. That's resulting you have to pay a huge amount as a gas. So this is what the gas griefing attack comes to the play. So gas griefing is sometimes see what I notice is that sometimes AI can't predict the gas because gas is something which is really based on the execution of the particular thing. Okay, see if they
This
are
CDBG's gas griefing is only on contract, or is applicable to any other non-contract in the crypto environment.
see in crypto world, whatever transaction you do know, you have to pay the gas. So it is that important in the Web3 environment because gas is something you have to pay on every time. There is no bypass for it, but you can optimize it with the proper optimization controls and all. You can optimize the code to a level to reduce the gas consumption of it. See, even if you try to give less amount, the transaction won't work. And see, I can show you one thing here. See, I was doing this CTF. See, I have completed so many of so many of or I have hacked so many of the contracts. See, these all contracts I am doing and I got exploited. So I am moving to next level. But on this level, the next two, this is where the optimization of gas come to the play. So at that time, only I noticed that there is a gas optimization need to be done, even if for the evil contract. See, if an evil contract was your contract, that we also need to give the gas amount. So that's the concept here. So every time when I try to solve this one, the gas option, I need to, I need to really optimize it. Then only my attack will be successful. Then only I can able to solve this particular challenge. See, I was using ChatGPT for creating the smart evil contracts and analyzing it. But still, gas griefing attack is something that AI can't. At the moment, AI can't. In future, AI can, AI could. But in the long run, it is possible.
Is it a top attack coming in a top attack in terms of difficulty?
Uh, as I told, this is something. It is a top attack. Yeah, considering it is can be a high vulnerability because in what we say in back to security, the case which I mentioned, the API key exposure. So we always flag it as yeah, high or critical because it impacting the business of the organization. So any vulnerability which affect the direct affecting the financial or business side of the organization, then it goes to the critical option. There is no doubt in it. So as I mentioned before, depending upon the we have to consider other things as well. Okay, so gas griefing attack. So this is the example of gas griefing attack. So this is a attack where this is the contract. Okay, this is a contract where highest bidder and auction kind of thing. Hmm. So I'll show you the code in full screen. So this is external payable and require message or value for the highest bidder and meeting on INF. This is the what we say. This is the condition to the uh, okay. So so this is the so the attack begins with the attacker deploying their own smart contract to execute the attack. Okay, the process commences by calling the smart contract, which in turn called the lottery contract. Okay, within the lottery contract, the bid function is executed and receiving funds. These lines ensure that new bid surprises the previous one. The previous highest bidder remain then previous highest bidder is then reimbursed. And the attacker's address is recorded as the highest bidder. What is the issue? When the program arises afterwards, it becomes impossible to outbid the attacker when the next person trying to outbid. Then the execution systematically fails. So it is to coming to when I say in simple words that if an attacker if an attacker calls this function a lot of times and that's resulting in gas problems and also attacker becomes the highest bidder here. Okay, then the next person can't outbid the execution because see once the gas see there's a limit for a block. See one block got this there's a limit for gas spending. Okay, if that blocks exceeded the given limit, then that contract become useless. So and ideally an attacker becomes the highest bidder because since after that if the block fails, okay, if the block fails and the last recorded address is attacker's address, so he's the highest address, so he can withdraw the money. Okay, so that's what I told you. Like if you want to attack a block, a whole block, okay, you can use gas as a mediator to attack such kind of a contraction. Uh, yes, that's how it is. Gas optimization and gas kind of thing, you have to be really careful about it when it comes to the point. Okay, and next slide. What is this? The next slide. Okay, what does this happen? So this is the explanation of the this is the attacker's contract. So this is the original contract, and this is the attack contract. See, attack contract is very much similar, similar than when it comes to the original contract, because original contract got lot of checks, lot of caching power, lot of things. Okay, but attacker knows the attacker just want to call particular logic in the original contract. So he can write a contract in a way, or only 4 or 5 lines can affect in billions. Okay, so attacker really can able to attack with the 4 lines of code to beat your code. Sounds interesting, right? Okay, so why does this happen? So whenever ether is sent to uh, whenever an ether is sent to a smart contract, it is possible to define a specific it is possible to define a special receive function that reacts to the incoming transfer. In attacker smart contract, a receive function is defined. So here, see, this is the receive function. See, the receive function, as I told, receive function is something you have to use it very carefully. The C function is a it's a special function which only seen in Solidity. Okay, I don't
So,
think it is.
Sandeep, other question: is this going to use during mining or only for the contracting phase?
Mining and contracting is there are a lot of difference between them. Because mining is the process of finding new blocks ID. Okay, so that is a computational and that is a mathematical problem here.
Mm-hmm.
See, it's a huge ask since this is the KECCAK 256. So that is a mathematical problem here. So a computer with a high brute forcing power. So that's why we are suggesting people to integrate GPUs. Okay, the graphical processing unit or the NVIDIA GPU and all. So these GPUs have a lot of capability to assume which hash is that. So actually, mining is just brute forcing only. We need to find the address of the next one. So that's called mining. Okay, and the smart contract is something which works on that block. Okay, which works on that block. So that is the difference between mining and smart contract. Smart contract uses a smart blockchain technology to function, whereas mining doesn't use blockchain technology. Mining is something a program who find a who finds a solution for a mathematical problem to obtain the next block. So that is the called mining, and this is the smart contract. I hope it is acceptable. Yeah. So so this is where I am. Yeah. Okay. The functionality intentionally consumes a significant amount of gas by calculating hashes. So that's what I mentioned. If your contract is if your contract is taking to significant amount for calculating hashes, then your gas amount is will be higher only, because it got that much of computational work to complete your transaction. So that's how the gas come to the play. If your code is really a huge complex code, you have to pay a huge gas as a computational fee. Okay, so that's why I always used to say that optimize gas in a manner that uses less computational power. See, when I was doing the when I was showing the CTF kind of thing few minutes back, you can see actually it takes some sort of time to time to confirm my transactions and all. So it actually works. It actually working on the blockchain side, actually uses the blockchain. And in blockchain what happens, if A pays B a particular amount, it is written all over the world. Okay, and that's what I showed you on Etherscan, because it is updated 9 seconds ago. This particular guy has sent this money to this guy. So it is a constantly updating ledger. Okay, it is always every second it used to update its ledger in a fast manner. So for ledger maintaining and for the people who mines the blocks, so these gas is ideally goes to them. Okay, this gas money, whatever money you took, no, it is the gas money will go to the person who do mining. So that's why the mining becomes the profitable kind of thing. Yeah, man. Some of my friends used to mine because they, if you are really into mining, then you have to spend huge amount on the hardware side because mining is a. I don't know if you see such mining places in online on YouTube. Okay, you can see how hard it is to mine the particular, particular hashes and all. So it is something really really hard. Okay, so I hope the gas transfer, sorry, gas griefing attack is clear because it's simply in simple words, gas griefing attack is the attack which utilizes or which exploits the gas of a target contract. That's it. Because you are making the you are exceeding the limit of the block to make stop function or to stop the contract function. Okay, so these are the things. So pictorially, this is how it happens. See, the hacker here deploys a malicious contract over here, and then on the first side, okay, on the second side, he uses his smart contract or evil contract to attack original contract. So, so this is how it works. Sometimes sometimes the code can be attacked with a code. So playing with fire like that. Mostly humans can't actually go and call particular function and to make the require or make to achieve the goal. Human can't do that much of thing, but humans can create a malicious contract to attack a contract. So that's how the smart contracts are getting exploited. Uh, Smart contract is as I told, it's a list of code. It's a code hosted online. You can really see the code what the code are doing, and plus with the help of AI, you can definitely see. You will get a better, good understanding of the code with the help of AI. So I was thinking to show you how an AI how we can use ChatGPT to implement or to to deploy a evil code. I was planning, but then I came to realization that it can be used as otherwise. Sword can be used to kill, and also it can be used to kill ourselves. So this is a two-sided sword. Like AI is always like that because AI can be used as a used for bad intentions as well. So it is not ideally recommended to show to create a malicious evil conduct and all. But see, for the if you are in future, if you are interested in auditing smart contract at that time. You can actually create a smart contract to attack this contract. Okay, no issues for that. But you have to be a by chat. Okay, you have to report what you got to the required team before you take an advantage of it. Okay, see, always work with ethically. That's it. Just a minute. Hello. Yeah. So I hope the picture of how the smart contract are getting exploited. I hope you got the picture of how smart contract are getting exploited. So coming to the next part, resources to learn. So before I come to this, I'm going to show an original report from Crutchfield. Crutchfield is a company who audit the smart contract, the real smart contract, and they used to they used to share their reports on their website. So this is the report of Crutchfield. They audited a smart contract. So this is that report. So this is a real world kind of thing. Like VLPP report which we have. Okay, so this is the finding. See assets in scope, critical high, and etc. etc. So his finding was something. What it called retest. See, this is the finding list. Vulnerability bypass the long duration period in vitro function. So this is categorized as high, and it is business logic one. Let's say that to explain this, I got an example. Okay, so let's say that we have one smart contract. Okay, and if you put money inside the smart contract, if you invest some money in smart contract, there is a function who says that you can't withdraw the money next 5 years. Okay, if you put your money to invest, you can withdraw your money for next 5 years. So bypass the long duration period in withdraw function can able to bypass these particular conditions, like 5 years you have to wait to you have to wait 5 years to withdraw your money. So you can, using this particular vulnerability, you can actually bypass that particular 5 years of requirement. You can actually bypass it. So that's how the smart contracts can be exploited. You have to find the logic of the code. Smart contract. What is inside this code? What this code are using? How they are implementing the access controls things here, etc. etc. So and see, you use honorable two-step. See, missing best practices. See, sometimes what happens, at present that particular smart counter doesn't got any vulnerability. Okay, but on the long run, if they miss the best practice options, in the long run it might be a problem for them, because best practices are always the best practices. And also in security, cyber security, there is a thing called compliance. Okay, whenever there is a cyber audit, and also they'll check some sort of policy if it is there or not. So if all the policy is there, then they want to issue the compliance certificate for them. Okay, so that's how it works. And compliance is something which is really important, or really need to be audited at the regular basis. So like that, we have to audit the smart contract here and find what are the missing best practices, and also we have to properly stick to the best practices when it comes to smart contracting or smart contract programming. Yeah. So this is one of them. And you for to get started, you can actually go through some of the people who actually become the smart contract auditor. I have one guy whose name is, I don't know how to pronounce his name, but he is the number one auditor on Codera. Codera is a platform like I guess it's a platform like Hacker One or something. So this is the guy who is number one on the Codera all over the world. So he learns solidity in this website. He used to say that learn Ethereum blockchain solidity basics. See, Ethernet is listed there. This is where I learned the smart contracting auditing. So the same goes for everyone. See, firstly you have to learn the some sort of logic basics. Then you have to do some sort of CTF. Then after that, get your hands on original contract auditing. Then you are done. You will become a smart contract security auditor. It sounds really good, no? When you have that kind of role in the organization. When you send an email, on the downside you can type that, but these blockchain security analyst or something. It is quite good. And I recommend all the peoples to go through this particular website, how to become a smart contract auditor, and also go through CRED Shields reports, as well as the CRED Shields founder or the CEO has a section done in insights, which is available on YouTube. You can refer that, and you can actually, there are people's in this blockchain community are only less only while comparing to Web2 security, but there are good peoples here. You have to, what we say, you have to make a proper way to become the own one.
Jaydeep,
So
can you copy that URL and put it in the chat for everyone?
yes, of course I can do that. So I'll share a couple of couple of good URLs to go through for everyone. Okay, so so at that time, it is really, see, it is really, firstly, keep in mind that it is really tough when you firstly start doing this. Okay, you can feel that you no longer able to do this, but don't go backwards. Okay, always think positively, and also always work ethically. Okay, some other people might think that sometimes after auditing smart contracts worth billions and you gonna you do know you're gonna loot all the money and then don't do that. Okay, we work ethically here, we spread knowledge ethically, so we should have some sort of ethics working in cybersecurity. That's the main thing which we have to you have to when it comes to cybersecurity, you must have some sort of ethics. I do believe that, and I recommend everyone to do that because privacy hacking is okay. Hacking can be done in both ways. One is for bad ways and one is for other ways. Like it can be used as a good thing as well. So that's how I used to work. See, that's why the company used to hire us because we hack the particular target and we show them how we got how they got hacked, and we suggest them how to fix it. Okay, so using this methodology, we'll create a healthy environment in the cyberspace, and see, gaining knowledge and using it for bad practices, it is not encouraged and it is not tolerated. First of all, and there is a other links as well. You can use Ethernote. I'll share it Ethernote URL with you, so you can actually start working with smart contract hacking. And also in YouTube you will get lot of resources, not lot of resources, but you will get some sort of resources to get started. And Ethernote is pretty famous one, so any beginner can do uh, start testing the smart contracts on mine. And also there is a, what is my slide, there is one more platform uh, which is like a game. Okay, it is a solidity game. You have to play the game, and but parallelly you will learn solidity. So that's how it is. So solidity, you can learn. Okay, first of all you can learn, but with now you guys are actually lucky. Okay, with the help of ChatGPT and other AI tools, your capabilities are increased to 10x or 100x more. You have to use the proper tools properly, and you have to yield the proper results in a proper manner. So that is how I usually do. Because see, for me, when it comes to the Web3 auditing, Web3 security, I was not having a single base on it. I was just working as a security analyst for a company, and at that time, we I work in a Web2 era. So it is really hard for me, even if hard for me to move to Web3 security. But after a while, you will start enjoying it. That's what my experience about the block three and all. And so to I'll share you one PDF if possible. Okay, I have some sort of basic PDF. I have to search it where it is actually. So using that PDF also, you will get a lot of idea how the things are working in the Web3 era. Okay, and Web3, okay, I'm talking about Web3 that, see, Web3 has what we say, as a really good advantage when it comes to Web3. See, in Web2, we have one server who hosting all the data, okay, which is, see, consider your Facebook, okay, you have Facebook account, you have hosted entire data, and these guys are selling it. Okay, they are making money with your with your data, and also that's how they are. Because if the product is free and you are the product, so but when it comes to Web3, no one owns it. Web3 doesn't do such things. Web3 never ever sell your data. Let's say that if I created one account, see, I have created one account in MetaMask. Okay, so MetaMask never ever going to sell my data, and MetaMask don't need to do that. Okay, so that's the beauty of Web3, and I hope the things which I talked is really helping you in some sort in your career. yeah, that's it. We have only 10 minutes remaining. So for the last 10 minutes, I was planning some sort of question. So look, for last 10 minutes, what we'll do.
Yes, I think Sridhar, you have answered many questions in between. Vanitha, are you
Mhm.
there?
Yes, Raj, I'm there.
Yeah, probably
So,
we can wrap up.
so your feedbacks, yes, feedback is very critical. So please do fill in and put it in the chat box.
Okay. Yeah, yeah, sure.
This is for members,
Yeah,
Sridhar.
I
This is
request
for
all the
members.
members to please fill in. The link is there. Yeah, I'll repeat again. Your feedback is very important to us. Please do rate this session on smart contract security, ensuring trustworthy agreement. The link to the survey, Menti survey, is in the chat box. Please go ahead and give us your feedback. Raj, can I propose a vote of thanks?
Go ahead, Vinita. Go ahead.
Okay, so let me have the privilege of giving the vote of thanks. On behalf of Isaka Bangalore chapter, I want to express our sincere gratitude for a truly successful session on smart contract security, ensuring trustworthy agreement. A special thanks goes to our esteemed speaker, Mr. Srideep. Your expertise and insights were invaluable, prompting thoughtful discussion throughout this evening. Your dedication and preparedness were very evident, yes, and they significantly contributed to the session's success. We also extend our heartfelt appreciation to the members of Bangalore Chapter ISACA, esteemed participants, and distinguished guests for your active participation. Your participation made this session truly enlightening. To Mr. Shrideep and everyone here this evening, thank you once again. Your presence and active participation since 5:30 p.m. have made this truly an outstanding session. Thank you all.
Yeah, actually.
That was very
Thank
nice.
you.
Thank you.
Bye.
Yeah, I'm looking forward to conduct other sessions with you since this session was going really good for me. So yeah, and again, I'm thanking you everyone for for accepting me for last 2 hours. Okay, and some of them might think that it's a boring thing. I'm sorry for that. Okay, the wrong wrong comments will be coming. Yeah, we know that. See, and so people are having both the decisions. So people always have their own opinion. So I'm trying to improve myself, and I hope you to see in future. Bye.
Thank you.
Yeah,
Thank
thank
you.
you.
Bye.
Bye. Bye.
Enjoy
Bye.
this session. Thank you. Bye.
Yeah. Bye. Bye.